Microphone. Uh, every damn time. I don't remember. Like some kind of thing where I don't remember ever. Damn time. I don't remember. Oh, I already heard that part. Like some kind of jab. Yeah, I shut that fucker up. Oh, that person. I mean to swear. Sorry. My bad. Alright, fix my hair a little bit. Oof. Yeah. Yeah. Oof. Maybe a little less light would be good. Yeah, maybe so. Maybe. Um. Oof. Oof. Anyway. Um. Hey, look at that. Somebody who's got a lot of digits in his name. Repeating forward and then backward. I guess he's in his declining years also. Yeah. Life definitely is one of them curvy things. Seems the backside is probably a little crappier and shorter, hopefully. I mean, hopefully shorter, not hopefully crappier, but crappier part seems guaranteed. So anyway, I thought I'd do a little bit of Ken. Just you can't like not respond in a sense just because he's just so arrogant and he's so fucking wrong. Ugh. I mean, when you're that preposterous, like I am Mr. Everything, which, you know, I am, of course. But I guess it's only a god can properly ridicule a faker. I mean, really, kind of, right? Yeah, it seems only appropriate. So, the subject is light, so I'll do a quick drawing, of course. Well, it won't be that quick. It'll be mostly quick. I might as well draw it ahead of the time before we even get to the subject. So he's just making some statements about the difference between ultraviolet or blue light and the neighbor to infrared light, red light. You know, they are neighbors to each other. So ultraviolet is right next to blue, and infrared is right next to red. Yeah. And it's yeah, just kind of annoying. You know, the invisible ends of the radiation. I probably should do this in red. Yeah, I think I have some red that'll work. And yeah, but like I said, he's just so freaking wrong about everything he says. And just annoying. Oh, I think I'll even write a word. Didn't write it very well, but I'll have to do. I'll put a little thing. I'll even put an arrow, and to make my point. There, I think I've done my job. All right, so on to the show. Probably. Should I sit here? Yeah, this is it. Might as well start from the beginning-ish. It's just so insulting.
On light, like red light versus blue light, it's like it's all light. It doesn't change, including a pile of cockroaches over on the largest photo forum in the world. You know, have you?
So anyone who disagrees with him is a cockroach, and he's afraid of the cockroaches, which, you know, I suppose it's okay for a grown big man to be afraid of little cockroaches, but it just seems kind of sissy and such.
You ever noticed how blue light gets radically shifted as it passes through a prism?
It's really not all that radical. Yes, we've all seen rainbows, and considering the actual distance of the projection, you know, it's really not that big of a divergence. It's very small little angular difference. It's just that the projections are usually rather distant. And same is true with a prism even. You're say a foot away where you're projecting the light to see the artificial rainbow. Well, the synthetic, not really artificial.
Now there's this neat little equation. Let's take a look at it here.
This isn't really an equation, to tell you the truth. This is a very simplistic formula.
Yeah, it's really difficult equation. E equals HV.
Yes. Now, when they do that kind of thing, it's like even the E equals MC squared thing. There's a certain givens that are in it. A certain obligation to make certain assumptions about the context in which the equation is correct. Now, the context is that it's not correct if your circumstance isn't the same. That is, as if you do two experiments where one experiment is a hurricane and one experiment is a dry day, you see, then whatever your formula is won't be the same. Like rain equals blah, blah, blah. That, that equation won't make any sense if you compare apples to the orange. You have to compare apples to apples.
That looks like a difficult one right there. Really hard. Energy equals Planck's constant, which the constant is pretty neat because it's a constant.
Well, that's a really great scientific explanation. I hope all the little kiddies watching heard that kind of shit. You couldn't say something better than a constant's a pretty neat thing, but it's constant. No, you say a constant is a pretty neat thing because what it actually does is convert something into units or some sort of consistent thing. You usually need a constant so you can create a product for which you have some kind of relevant use. Without constants, you couldn't break things down into Kelvin or calories or horsepowers or any of that kind of stuff.
Times the frequency of light. Wow.
So it's energy equals Planck's constant. So let's just make up a number, 2 times the frequency. Now, obviously, if you're going to do 2 times the frequency, it wouldn't make any sense if you're comparing like 4 horses to 1 horse. So if you did 1 horse of infrared and 4 horses of ultraviolet, this equation won't work because you're cheating. You're not in the right context of the equation being correct. What you have to have is equal quantities to have equal energy, you see. So it doesn't, this formula has nothing to do with making comparisons between red and blue light. It really doesn't, unless you're using the same quantity. And that's a time interval in this case. That's what the constant probably has in it, is probably a per second or per some unit of time component. So I guess it's time for the explanation. And I've done this before, but it's just such a simple thing to explain what a photon is. So photons, let's say they're going that way, just for fun. The blue ones, okay, and the red ones. So the difference between them is the distance between them. You see, that's the nanometers. And so you could have like 400 for the blue and like 700 for the red. So this is a little bit off in that. See, this one's a little bit staggered, but it should be a little more staggered actually. But anyway, and eventually after you go 3 of these, they will actually line up again, which is kind of, they'll have 1 to 1, and then they'll go and do it again, and the pattern will get repeated. So there's a certain consistency in their residence because they have a point where they will line up again, numerically. I think it's a multiple of 4 actually, but it doesn't really matter. So the point is they had, see, it's like you do 3 times 7 is 21, and 5 times 4 is 20. See, so they're very close. They line up again. That kind of thing. You get it? Anyway, so what you have to do is say in a moment of time in that equation, the E equals H times V. You could see that yes, blue light will be twice as intense, maybe even twice plus one little ton, um, because in a certain given amount of time, that's only how many tons we'll be able to get across. So that's the energy comparison. But intrinsically, if you measured by only the tons rather than the time, and if you only had one ray of each, you see, then they have an equal amount of energy. So it's only in a certain amount of time, that the energy is different, because obviously something where there's a machine gun is, you could say, more powerful, okay, than the 9mm. But if they're both shooting 9mm bullets, the bullets aren't any different. It's just that, yeah, in a given amount of time, one gun will shoot more. So, now the other story to this is, though, is that ultraviolet light, the blue light, behaves differently than red light. So this is the tipping arguments. Now, these are exactly arguments I've been going over, but I'll just do it one more time because, it's kind of funnish. So inside electrons, there's a mechanism where, their stability is tenuous. And depending on the kind of action they're being exposed to, there's a kind of idea of a tipping idea. So this, well, you can't see the color difference. That would help if they had a color difference. And, if I made maybe the blue one, I put little lines across it, and then you'd get the idea that there's a building, a pedestal standing up. And you can sort of understand that it will have a different, depending on the mass of something, or its length, different variables, how well it's glued to the base, all kinds of things will decide how easy it is to knock it over, and it'll decide the period of time it takes to knock it over, how long it swings. And so if you were to throw rocks individually, if you're an idiot, you'd throw just 2 rocks real quick and nothing would happen. But if you're clever,
hey, Gary,
you'd
the Earth is flat, you fucking dumbass.
Yeah, Joe, you're just too not interesting. No one's inviting.
So fuck you, asshole.
Not interesting. Fuck, troll. You're just proving you're a troll, Joe. You're just proving it. An immature internet terrorist. I mean, most of them are 15 years old, or 12, or, some kind of adolescent. They're not grown fat men. Jeez, go play with Piero and friends. They're all stupid and ugly like you. Anyway, so there's the tipping point. So the idea would be is if you throw the rocks at the right interval, what you'll do is the first rock will push it, it'll rock back, it'll rock forward, and then you hit it again while it's in this weakened position, and it'll fall over. So infrared light.
But the Earth is flat, though, right?
No, I don't, Joe. So, but you're just proving. Right? I can show this to Piero's room and just say, look what a troll this little Weasley cunt is. All right, so there's a tipping point. So infrared light, it does this thing, okay? It does this just right for electrons. And ultraviolet light, or blue light, tends not to be very good at doing this tipping thing. So it does a lot of reflecting and breaking and pieces flying off and all kinds of trouble. It actually produces infrared radiation. The ultraviolet light goes in and extra, okay, just because of the amount, remember. So if a stream of ultraviolet goes in, it can create a much longer stream of infrared. So for a much longer period of time, you can shoot infrared bullets. That kind of thing takes place, and it heats the atoms because of that conversion. So it doesn't mean, though, the ultraviolet light has anything called more energy. It's just a specific kind okay, of energy that electrons can be more or less sensitive to, or can cause reactions that are different than the reactions going to be created by infrared contact. And that's it. So you really don't know what you're talking about, Ken.
Oh, yes, glass. If anybody tells you delusionally in their sick, twisted mind that all things being equal, which of course they never are, ED elements, the composition of the ED elements, that light just shimmies through 5 elements and hits a sensor the same way light would pass through an identical focal length lens with 13 elements, and it's just the same. People like that are smoking crack.
Yes, it's a different reason though. So now he's talking about compound lenses and whether the light is going to be able to be transmitted through these lenses without some degrade. Now, it's really not going to get too degraded by the diffraction problem, the prism problem, because that's sort of balanced in the sense that it does both. It does it at both sides to both entities. And so in a way, it probably balances out, because for every bit deflected one way, it deflects the other way. And so that can all equal out. But the problem really is that the more lenses you have, the more likely you are to have reflections on those glass surfaces. The average is 4% of the light. And that average can be adjusted using quantum mechanical theory. But the theory really is just the fact that glass can be polished to an appropriate thicknesses. And in lenses, obviously, that's a little trickier because there's a slope and you can't control this entire surface. So at some point, you're going to have these higher reflectivity points and lower reflectivity points. And so that's going to create some distortion over time, obviously. So yes, more glass isn't, unless it's really thick, more glass thickness is okay, but more surfaces of glass is going to tend over time, you keep doing that, you'll, I think, eventually cause some degrade. You'll definitely need more light to take a picture. And sometimes that's good because then you can open the aperture wider and frankly, and get a more specific focal length, which is sometimes quite advantageous. So it can definitely, depending on what kind of lens it's the purpose of the lens, it could be a useful defect and such. All right, so we do have some comments. Let's do some of that now. Let's switch back to Ken, maybe. See if we get a guest or anything. What do you think gravity is? It's a field perturbation caused by a hyperboloid, of course. No, it's field energy. It's photons you can't recognize because they don't have a frequency. See, imagine these little photons without any frequency. What if this was all jumbled up and there was no frequency, no standard frequency? Like the second one didn't come at 700 nanometers, it was like 15 nanometers, and the polarization was different on each little ton. Well, then they'd be totally unrecognizable by any device that we have to recognize photons. So if the rays don't have consistent polarization and they're not coming at a consistent frequency, we actually have no way to put them on the electromagnetic spectrum. We have no way of detecting them, except by doing this. Yeah, then we can detect them because they just push this down. Yeah. Do you think that gravity is a result of time dilation? No, velocity causes time dilation by forcing the matter to do what it's not doing now. The matter now is doing this. If I force it to do this directional thing, then it has to do this slower because it only has 2 feet and it can't dance any faster. See? That's the whole problem. So say if you're a dancer and I ask you to move sideways as you're dancing, you're not going to be able to do the steps as fast. It's just a fact. Yeah, it's simple. Very logical. Logical answer. Do you think the whole bent space-time thing is right? Of course I don't. No, I think the possible reason for why light may bend around objects, well, it doesn't bend around objects. It gets diffracted by electrons. Electrons can do two things when you hit them, okay, with a photon. They can go straight because the field allows them to, or they can go crookedy, okay, if the field doesn't. So if they're stuck in a field and that's a benign field, a soft field, well, then the photon goes in, hits the electron, electrons accelerate a little bit, and it re-emits the photon. But in this case, if the electron is on a field line close to a material object, an EMF line, then when the electron hits it, the electron does not move straight. Therefore, the photon, when it's re-emitted, is re-emitted at an angle. That is diffraction. And that is the source of any light bending. But light can't be bent any other way. Gravity doesn't bend light. It's never been proven. The experiment that proved Einstein right back in 1920, whatever, 1918, I think it was completely bogus, and it was never repeated successfully. The two other tries on eclipses both failed dismally. And in spite of the fact that the Hubble telescope doesn't have to deal with light scatter from the atmosphere, the reason why you have to do these experiments without an atmosphere, because the sun scatters it and you can't look up at the sky because it's full of light scattered from the sun. Yes, the Hubble telescope can see clearly all the time, 24 hours a day, and it could just go right up to the edge of the sun and lens things all day long, and it doesn't because lensing doesn't work. It's a fraud. Bent space, light may bend around objects with a large masses because of time dilation. Well, again, it's time dilation is a consequence of absolute velocity, not anything called relative anything. And it really doesn't have anything to do. I mean, velocity has a lot to do with acceleration, of course. So if you're accelerating very fast towards a body, you're going to have time dilation. But you have to be going very fast. And obviously, light's going the speed of light. It can't go any faster, so it can't really time dilate. You really can't time dilate something going the speed of light. That's retarded. Fundamentally retarded. Let's see. Ooh, hello, douchebags. I don't know what that means. Light does not bend. Very good. I say the blue shows more. It doesn't really show more because of compression, polarity versus red expansion. Well, again, that statement. All right, compression and expansion. That's your contention. Something's expanding and something's compressing. Well, you're not going to draw a picture of it, I'm sure. You're not going to be able to explain how it does any of that. So I think my answer certainly wins the Occam Razor Award, but I think my answer also wins the My Answer Makes Fucking Sense Award. What we call Earth isn't flat, obviously, since there is high mountains and deep oceans. Well, I don't think that's the argument the flat earthers are contending. They're saying that Earth is lateral or linear. It's a linear Earth, not a spherical Earth. So you're not even playing along fairly. But I'm not convinced we live on a small ball either. Well, I know it's not that fucking small. I mean, realistically, it's pretty fucking big. It's a lot bigger than one of my testicles, so that's pretty big. The trolls don't realize that while they get their wank in now, this was probably one of the reasons Eminem stopped the Tiny Chat. Well, it was definitely the reason I stopped was, yes, who wants to bother with assholes all night? But it also stopped just because there was no, everybody, even the non-trolls were pretty much assholes too, so what's the point? It's just because a social place for billiard trolls to do a daily taunt. Oh, bastard trolls. Stupid is a pandemic. It's everywhere. Yes, well, this is a big problem. Idiocracy is on the move. It's coming right for it's heading right for us, and we should shoot it quickly because it's going to win. Yeah, physics of a porthole. I don't know what that means. LOL. Yes, but they do make portholes on submarines. Actually, they polish the glass to create the perfect thickness that will reduce the amount of reflection of light, just because they're usually looking into a much darker place, and any reflected light is going to make it impossible to look out the little window. Because it's a push, not a pull. Exactly. Agree. Very good. I'm from who cares? Walton Beach, Florida. Gee, somebody asked you? Gee, I didn't do that. I'm a Florida native, I mean, too. I don't know if that's a good thing or not. There's a lot of bugs and diseases down there. You know, no, I like Florida. I was a Louisiana native. Not really. I mean, I was born in New Jersey, but they took me to Louisiana shortly after the birthing. It is very daft to discount the bendability of light. Well, daft, you say so. You don't know. You know what? You want to put real money on it, asshole? I'll bet you $10,000 you can't come up with one piece of good evidence. So don't call me daft, asshole. Why don't you? I mean, I don't know how to. I mean, I know it takes a little bit of work for you. You have to actually research something. But why don't you research the Edinburgh experiment and see that it's never been successfully repeated and that they never repeated it outside the margin of error? And then why don't you go find an image of solar lensing, the sun lensing? Why don't you find a Hubble image that could be taken every fucking day of a sun behind the sun getting lensed, or a galaxy behind the sun getting lensed? Why don't you show me one fucking image and then tell me I'm daft? You fucking cunt. Yeah, it's why I live in Texas now. Ha 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 ha. I can link an experiment 1 second. Yeah, you're gonna need a lot more. If it's a bad experiment, what do I win? Do you have to give me a $50 donation or something? Is it really? I'm not gonna look at your crap if it's easily detected to be a fraud or a fake or useless as evidence. I mean, I'm so sick of you people and your fucking cunt, useless, fucking trollish linking. Okay, that other asshole did that. He linked to an experiment, and you read the whole PDF, and at the end of the PDF, they say, well, our margin of error was plus or minus 10, and yes, well, our results are 15. So yes, we're outside the margin of error. I mean, they're in the margin of error. They weren't, their number was bigger than it needed to be for it to be an illegitimate experiment. Well, I don't care. AAS Nature publication. Yeah, guess what? I've written to Nature. They're cunts. But anyway, go ahead. I'm just saying, you're going to say it proves gravitational lensing. And I'm just going to say, if I do a video exposing it as not demonstrating lensing, will you do something like admit you're a stinking, lousy cunt of a troll to sit there and call somebody else daft when you can't produce evidence? Okay? That's all. I just want you to in some way prove to me that you're recognizing that you're the fucking asshole. You're the daft loony poop who can't talk honestly, who hasn't done the research. I've done the research, cunt. If the evidence was out there, I would have found it by now. I've been looking for 2 fucking years. I've seen every single lensing image in the universe, and they all fucking suck. They don't make any rational goddamn sense. So you're not going to beat me on this subject, you cunt. Well, yeah, he called me daft, asshole. So what, do you think they did I say anything about they distorting anything? I'm saying they're shitty pictures describing lensing, okay? A galaxy, you don't even understand what a galaxy is. A galaxy is a flat fucking thing, asshole. Okay, you turn it like this, the gravity's really thin going this way, jackass. See, gravity works by mass and thickness. So if you're going to fucking lens next to a galaxy, the galaxy would have to be this way. Okay, that's the only way you could ever have lensing, but it's the only way the fucking light would be in the gravity long enough to get lensed. But you don't know any of this fucking science, you little Weasley big mouth fucking cunt talker. You don't have any fucking knowledge on the subject specifically, and yet you have the arrogance to sit there and call somebody else daft. I mean, fuck you. Do you think that galaxies and objects are naturally distorted in shape? Well, again, show me a picture of this distorted galaxy that proves that it was lensing that causes the distortion. Go ahead and prove that somehow. And do it with a rational argument without using dark matter, okay? Without using complete fake it fudge, okay? Explain how gravity could be there. The lens has to be made of gravity, you jackass. Do you understand what that means? That means to bend light, if the lens is 500 light years across, okay, that means the gravity has to be really strong, 500 light years away from the center of the gravity. Do you understand that shit for brain? And to have a lens that pops on both sides, it means that both sides have to have that kind of gravity. And for you to have any kind of image size of resolution, it means the gravitational field has to be fucking huge. You're talking about 2 billion light years away, looking at a galaxy 2 billion light years away. You couldn't fucking see it unless the lens is monstrous. You dumb cunt. Let's see. I didn't call him a... no, I agree. I called Glow a cunt before you did. Stuff you. I don't even know what that means, but fuck you, whatever you're doing. Yeah. I mean, the other explanation is that Hubble images are faked. Well, you're saying they're faked. I'm saying just look at them, asshole. If you think those images can be put into a rational formula of gravity, where, you know, just from your own experience, you really should understand that gravity gets really weak really fast. Okay, I mean, the gravity where the Earth is from the sun is 0.0014 feet per second. I mean, meters per second per second. 0.001. It's incredibly weak gravity. That's why Einstein said it would be a surface phenomenon, lensing. And the only way he could make it work was saying, well, look, time dilation means the light will be in the gravity twice as long. So now I can make this make sense. But it really doesn't make any sense, because you can't bend light no matter how big the gravity is, and how long you let light sit in it, because light's a force. Light isn't matter. It's a force. It's moving the speed of force. Forces move the speed of force. Gravity moves the speed of force. Magnetism moves the speed of force. And light moves the speed of force. Forces aren't matter. You can't move them with gravity. You can't move force with force. And that's, Maxwell will prove that. Everybody proves that. Two magnetic fields don't mix together and turn into a new magnetic field. They're each independent causes. Each gravitational influence is never diluted or mixed or changed. It is what it is, and you have to calculate it as individual gravitational effects on any single charge you put in any kind of field, because force doesn't change force. Idiot. All right, anyway. So quit putting words in my mouth. I didn't say anything about faking anything. What I'm saying is they're drawing silly and stupid conclusions on mushy evidence. The evidence sucks. Okay, there's blobs of light in half-hour time exposures. Okay, half-hour long time exposures. You got to be a little bit sensible and say that, yeah, you might end up with some kind of fucked up thing, like something might have flown in front of your fucking lens in a half an hour that might have screwed up your image. Let's see. If light is an electromagnetic wave, then it's bending a bunch within its waveform. Yeah? Well, whatever. Of course, it's not doing any of this bending crap. All right. Wave isn't, well, after effect isn't even an accurate description. I mean, anything at a frequency can be described as a wave, but it's just silly to say, you know, cannonballs. When I shoot cannonballs, 1 a minute, I'm waving cannonballs. No, I'm not. Well, time dilation in GPS satellites is a different effect. Again, that's caused by velocity. And the reason why we are moving much faster than those satellites, that's the joke here, jackass. If you really look up GPS, they don't have to move the satellites forward, they have to move backwards. See, because we're moving too fast. We're the thing looking like we're going faster than the satellites look like they're going. So the satellite's going 20,000 miles an hour, and we look like we're going faster. And the reason why is because we're in the heavy gravity, which means all day long you're doing this. Bouncity, 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 bouncity. And if I change the position of this, you can sort of understand that bouncity, 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 bouncity means that you're fucking going a lot of distance. That this big bouncy line is a lot of distance. See, the universe doesn't do this round circle-y thing in any kind of perfect way. Everything is a least. Everything is jiggling all over the fucking place. So guess what? Yes, the bouncing ball, like a basketball, if I go run across a basketball court, I don't just move the ball 100 feet. The ball actually travels, you know, hundreds of feet, thousands of feet, because it's doing all this up and down thing. Fuckhead. Anyway. Yeah, I mean, look, it's not everything you've been taught, but the foundations of quantum mechanics are bullshit, okay? The two-slit experiment is bullshit, okay? The single-slit experiment's the whole game. And then what did they do with the single-slit experiment? Yes, that's right. They invented Huygens, this idiotic principle that applies to no other aspect of physics. So they have a thing called a principle that they apply only in one circumstance. Yes, so that's where it all starts. It starts with the lie of the double slit experiment. Like the double slit's creating this bizarre pattern, when Newton knew that a single aperture creates the same exact pattern. That he knew hundreds of years ago, the very thing they were like, surprise, look at this weird pattern. Oh my God, how do photons do that? Yeah, Newton knew about it, for fuck's sake. So yeah, physics is quite, you know, I'm sorry, but I mean, they're looking like 7-year-olds, okay, to get fooled. Yeah, you look like a 7-year-old. I mean, yes, this is the kind of thing where you say, yeah, I can fool a 7-year-old. Because they obviously didn't do any thinking. To be fooled by double slit interference pattern when you know single slit interference pattern exists, it would be just silly to worry about the double slit pattern. The one that's fucking interesting is the single slit pattern, right? Well, how the fuck did one slit do it? Man, that's a pretty clever thing. Why don't they ask that question? How does that single slit do that? And like I said, their answer is just made up to solve their mathematical problem. I mean, you know, I'm sorry, but it is true that physics has been completely snookered, okay? I mean, Einstein, I like Einstein. But Einstein, he came up with, you know, a really great story, right? It was a story. The bend space and the relativity thingy does this little blah, 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 blah. And they fell for it. And it was crap. And then they were stuck with this stupid idea of pull forces, which is retarded. And like I said, it wasn't all Einstein's fault. It was really Maxwell's fault because he's the one that started making forces all, he decided to turn everything into electromagnetism because he was an ether nut. I mean, Maxwell was an ether nut, for fuck's sake. So yeah, he converted a light into electromagnetic radiation just because it's going the same speed as magnetism. Now, does that make sense to you? That you should do that? You should turn fucking light into something electric and magnetic when its only similarity is it's going the same speed as magnetism? And gravity also. Gravity now has to be electromagnetic. It's sparkly arcly. No. Anyway. Just pretty irritating. All right, so I'll go back to the comments are almost as bad as Ken. For fuck's sake.
I mean, do they think that this equation, which is a constant, is wrong? Energy.
No, but you're misinterpreting the meaning of the equation. Is my simple argument to you. You have to understand that if you use a time interval, of course the blue ones are going to win the energy race. Because, yes, more of them are getting shot per second in a ray. But I'm just saying if you go by actual tonness, they have the same energy.
Equals Planck's constant times the frequency. Now, you see the neat little chart here before that? Look at that.
It's just the colors from purple to red. Oh, very cute. Anyway, so let's get to the part where he says all this. He just does this insulting part, so I figure I'll do that. And then we'll be done with the Ken video for the evening. But the whole debating me, how can anybody debate me? I'm the king, I know everything. Nobody could possibly debate me. How dare they even think they could debate me?
Grenades. Boom! And then the electrical linesman would have a hissy fit. So anybody that wants to have a debate with me about the nature of blue light, how it reacts through lenses versus red light, well, it's just light, It goes to the lens the same.
Okay, yes, I want to have the debate. I'm sure there's other people, and it just seems like you're going to keep trying to weasel out of any kind of confrontation with the people you perpetually and incessantly insult, which just makes you the cockroach, in my opinion. You're the one with the hyperbole, you're the one making all this big talk, all this shit talking, and no put up. Whoa, I just subscribed to his channel. That's a stupid thing to do, Gary. Yeah, no, I started to hit the play button.
I mean, there's some cockroaches. And that's what they are. They're mental midgets and cockroaches.
All right, mental midgets and cockroaches. Like I said, what good is this conversation? You're calling other people unreasonable, like they're the ones who are the fanatics, okay? Because they're waiting for a theory that's explanatory and rich and detailed and all that stuff. And all you're doing is this hyperboloid inverse counter space, blah, blah, blah. And you're saying, gee, you're all idiots because you don't think inverted counter space makes a great deal of sense. Oh, I'm honestly telling you, I don't have any agenda. I have no God in this race. I'm just looking for the fucking truth. And this crap you're talking doesn't sound like anything the truth could look like. It sounds like a preposterous truth.
Excuse me for being blunt like that. I want them to refute this. It is irrefutable and it's undeniable.
What is? Again, see, again, he doesn't even define the question. It's such a straw man. What exactly are they arguing? Are you telling them that blue light is intrinsically or fundamentally, just by its very function, more energetic? Well, it's not. Okay, it's only more energetic circumstantially. So it depends on what circumstance you're measuring the two things in. If you honestly measure the radiation, then one quanta of radio waves is just as energetic, has just as much potential to disrupt the universe as one quanta of cosmic rays.
It's called Planck's constant. Energy times equals Planck's constant times the frequency.
Right, and that's only in a timed interval of a ray that would be of more than one quantity of the substance. So if you're going to allow this to be a flow rate, and you're measuring hoses or something. No, we're measuring the water. The water's the same.
Blue light has higher capacitance and higher energy than red light does.
All right, higher capacitance and higher energy. So he's combined these two subjects now. Let's understand what capacitance is. Capacitance is when you actually put mass into something. Okay, you fill it with electrons. That's what capacitance is. Capacitance is like a battery. You'll make a capacitor heavier or lighter as you charge and discharge it, because you're putting actual things into a capacitor. Light can't be a capacitor. It has no terminals.
This is an optical fact.
Again, it's an optical fact. Everybody's supposed to just say, gee, you're right. It's just so obviously an optical fact. It's not. Whatever that even means, it's an optical fact. There's all kinds of blue light racing around. It's hitting my eye right now and making me think the screen is white when it's not. What's the optical fact?
People say, well, that guy doesn't have a degree in optical physics. Oh, really?
I don't even know if there is a category of optical physics. I mean, just don't think so.
No, I just spent half my life, reading every advanced book on field theory imaginable.
Well, when you say read, you mean eat, and it's not the same thing. Eating every book in the world is not the same thing as reading every book in the world. So I think you're a little confused.
Written to myself.
Technically, I don't know if I'd really call them books, whatever they are. I mean, the one I'm reading right now, I'm a third of the way through it, and it's just such a mess. I mean, just a mess. It has no continuity, and all it does is the same thing you do in these videos, is just say, it's inverse counter space, hyperboloid sandwich, man. God, Jesus, do you think Mother Nature doesn't know how to make a hyperboloid sandwich? I mean, it's the simplest sandwich in the world to make a hyperboloid sandwich. Frankly, I don't know what you really think somebody of a scientific bent, somebody has a passion for knowledge and the truth, is going to be convinced by your down homey I'm going to compare physical phenomena to a ham sandwich. Maybe a spam sandwich. Yeah. And everybody will know exactly what I'm talking about, because you have to take in physics, you got to think about stuff, and that's like putting your knife in the spam bucket, and then you smash it on the bread, and then you smoosh it together, and the bread sticks because you got some spam in it, right? So that's like magnetism. The bread gets all stuck together by the spam. I don't think so. That's another one. I mean, what is this maniacal laughter crap? I mean, you're just turning yourself into some little Simon Bar Sinister or something. Dude, I am really getting to them now. I've got hyperboloids in their brains. I mean, fuck this crap. I mean, really, whose intelligence are you really trying to insult? Your audience? Your own? I'm not accepting your insult, asshole, because I'm saying, look at the game player. I mean, bullshit alert, wank, wank, wank.
Debate with me about light?
Yes, that's right. Everybody wants a shot at you who has a brain, because what you're saying is crap. You're lying about science, which is, like I said, to a real nerd. Oh, that's not good.
Have a debate about light and lenses.
Yes, let's have a debate about your fucking knowledge, which is weak, thin, and poorly interpreted by you.
Are furious. Actually, the main reason they're furious is because people are starting to see. It's not like mass hysteria. It's like they're starting to see something isn't there.
No, we live in a world full of dumbass truthers and liars like you. These fucktards who think they have the truth. They know Bill Clinton raped 9,000 women, and Hillary Clinton stole a bunch of uranium, and she's trying to make a goddamn fucking cunt, femi bomb. She's gonna try to blow all our balls off with her femi bomb. Yeah, everybody with a brain is so sick of you cunts. You unaccountable, shit-talking, motherfucking truthers. Yes, anyone who's rational on this goddamn planet has got to be sick to death of the unaccountable pontificators who put nothing on the line and who run from a fucking argument. Yes, and that's what you qualify as, a fucking big-mouthed coward.
She's starting to compare things. You're like, oh, geez, I just compared this needle 6-element 105mm f2 against this 14-element abysmal trash that is really, really flat, and the color is just...
Yeah, whatever. Really, really flat. So if it's got 15 elements, it's probably not going to be too much fucking goddamn flat. But I mean, it's probably a little bit too universal, right? I mean, they're trying to make the lens that does everything. You know what I mean? I mean, it takes pictures of asteroids in space, and it can take a picture of the dust on your desk. Yes, anybody who wants a lens that does everything is probably a bit of an asshole.
Washed out. And you certainly can drag the saturation slider in Lightroom, can't you? Yeah.
Well, if you can do that, then I guess there's probably an adequate enough contrast, and again, I see there's certain times where you want a longer exposure, and compound lens will just give you longer exposures, which is kind of convenient sometimes.
But you can't add micro contrast.
Well, actually, you can by just having more, the longer exposure.
There's some other things you can't change, like the bokeh, the nature of the back.
That's whatever the bokeh is, right? That's a scientific term, bokeh. Yeah, I'm sure. The light bokeh. Yes. Well, maybe you're a fucking photographer who don't really give a fuck about bouquets. You just care about your picture having the information of, color intensity. And you don't even care if it's in black and white. You just care that it has the information and you can exploit it later.
How did you think a prism works?
Okay.
Why did you think?
How do you think a prism works? Didn't I just explain it? I mean, light is a compressed capacitor. It's compressed capacitation.
I think blue light went the way the hell over here, and red light did not get diverted that much.
Well, whatever. The amount of the deflection is based on the speed of the electron, and obviously, if the electron is moving a little faster because it got hit by more of the little blue things in the same amount of time, then obviously it would travel to a location that was more bended. Yes. If you go further around the curve, oh, look at that. My direction changes by almost 90 degrees if I go all the way around the curve. Yeah, amazing.
The very simple analogy, and I'm going to make this really, really simple, is if you have two runners, it's like a fat guy like me that isn't running that fast, and like an Olympic runner. He represents blue light. He has a lot more energy. He's really fast.
So again, he doesn't have a lot more energy. He has more tons per second. He has more, he's given because he can fit them in his pocket, kind of a thing. More stuff will fit in the same space of the blue stuff than will fit in the red. So if you're given the same box to carry your energy in, you can only put so much energy in. If it's red, you only can put half as much energy in the box because the reds are further apart and take more space. But it doesn't mean the reds are weaker than the blues. So I just keep reiterating that. Doesn't mean the reds are weaker than the blues. You're cheating the facts here, implying stuff that is incorrect. Frequency has a consequence. The speed at which you do something in terms of vibrate it will decide whether it breaks or it doesn't break. It'll decide lots of things. It doesn't have to do with the energy. It has to do with how the energy is manifest. And our perception that blue light is more energetic is just a perception based on the fact that most of our cells are damaged by blue light. It's not compatible with cellular structure. as compatible. Obviously, we have to survive it. But yes, if it wasn't for the magnosphere around this freaking Earth, there wouldn't be life on Earth because it would be getting irradiated every day and zapped into pieces. So if there was going to be life, it'd all be turtles all the way down. And I like turtles, so it'd probably be a better universe that way. But anyway, I think that's enough of this. Ken trash. So again, but just the gutlessness of it. Well, let me play a little more. Maybe further down here, he talks about debating again. It's just he's laughing about it as if we're not entitled.
Longitudinal chromatic aberration comes from. It is the nature.
Chromatic aberration. What does that mean to anybody with a brain?
This is not only a capacitor; it's an insulator. Everybody knows what glass is.
Glass isn't a capacitor. I mean, what it is yes, it's capable of holding charge on its surface, but it doesn't do it efficiently, and it's hard to get the charge off. And so there's only special circumstances where glass, in most cases, glass will be an insulator, but there are cases where glass will acquire the charge, like any other thing, usually, of the field that it's in. But it doesn't charge and discharge like a conductor, in the sense it can't do it rapidly. You could never throw frequencies at glass and get anywhere. Okay, it's not gonna accept your rapid charging and discharging. Well, unless you have it, completely surrounded in a copper jacket or something.
All insulators are also capacitors, Even a rock.
No, I don't know that at all. So, but whatever, it doesn't really matter. Insulators are just bad conductors. See, conductivity is just a scale, and everything is a conductor. And there's just really good conductors, and then there's really bad conductors. There's no real such thing as an insulator.
Rock, which is an insulator against, like how they make rocks, make dams out of rock. Even rock has.
Well, no one would ever think that rock is a really good insulator, but whatever. It depends on the rock. Obviously, iron ore would be a shitty insulator, electrical insulator.
There's a porosity to it.
Porosity. Now, so there's another concept. So now he's gonna go all the way back to 400 BC and dig up the explanations of the antiquity, where they're going to talk about angels and demons living inside the pores of the iron. What's the point of doing that?
Where it will store water. Okay. Some rocks are.
Okay, no, and all this is just rubbish. That has absolutely nothing to do with the subject, porosity.
So porous that they would actually pour them on a channel and cause the rocks to split apart. You ever think, well, rock is rock.
Pour them on a channel? I don't even know what he means, but I think what he means is you saturate the rock and then freeze it in the cracks. But
is an insulator against water. That's why they build dams that are big boulders. Yeah, but rock also has a porosity. It's not very much, but it does have a porosity.
Well, whatever all that mush means. So you're saying that somehow the glass deflects, whatever, absorbing electric charge from the light hitting it, and that's what is deflecting it? I don't know. I don't know what I don't know what this mush even means.
Let's just think of a sponge as a porosity. You stick a sponge in some water and soaks up that water. Glass also has an electrical porosity, and that is called, wait for it, it's called dielectric permittivity.
Yeah, well, whatever. You can call it anything you want to, but I'm going to say Tinker the Hyperboard Bell. All right? It's just a fairy. It's, just a word you made up. It's just crap, and it's just about as useless as it gets. So let's see if he talks about the debating thing
Electricity
again.
when we put a solar panel up there, sunlight hits it. Guess what happens when you hit a solar panel with red light? It don't put out much charge. Guess.
So again, it's a volume argument. So you know, if it depends on how much light you're exposing it to. But again, the argument is that for a given amount of space, you can always shove more of the higher frequency thing in. So the fact that you can shove more in doesn't mean it has more energy.
What happens when you like drop some serious blue end spectrum light? Oh my God, the power spikes a lot. Planck's constant. Yes, girlfriend.
Whatever. I'm not your girlfriend, but yeah, I don't even know the spectrum on solar panels to tell you the truth. So I can't make an argument about that. I think the fact that they do have glass on top of them means that they're probably filtering some UV light, but whatever.
Red light and blue light are two different things. They are all part of visible light that passes through your lens to hit your sensor. So the next...
Well, once again, the atmosphere is also blocking the UV rays, and there's different reasons not to believe that it's really heavy UV exposure. And the UV exposure, again, also creates heat, which is a problem. The UV rays go in, they're converted to infrared, and then the infrared is obviously the infrared light. But if it doesn't go in the right way, it won't do the chemical reaction thing that's useful, and instead just create heat, which is not a good thing.
Moron that tells me that a 13-element lens is no different than a 5-element lens.
Well, again, the part of the argument, I would say that you are correct to say there is a difference. I would go with the argument of reflectivity, that the more lenses you have, the more photons you're going to end up reflecting. And so that's lost potential for the photograph. But again, if the lens is for a specific purpose, like time exposures, that would be kind of irrelevant. And also, if the light getting reflected is substantially light scatter, that would be even more important in terms of some of this light ends up getting polarized as it goes through these lenses. And you might end up with a clear image because you've taken scatter out of the equation. So you've taken noise out of your field of view. But I don't know all the technicals of glass lensing. So, I mean, I'm frankly not an expert on camera lenses and their compound positioning and all the rest of that stuff. So I can't make hard arguments. I can only make basic arguments about what factors I would consider if it was my obligation to build a 15-element lens. These are the things I would be considering. All right, so enough said. You're chicken shit. Now, put up or you should shut the fuck up. And you're not willing to put up. You talk this puke like you've won all these battles, that you have victory after victory after victory, and you're unwilling to pick up a sword and fight. And it's just lying about your accomplishments is just about as bogus as you can get. Bogus. Yeah, Ken the bogus. Apoplepsis. Simplicity would say, put up or shut up, pussy. I think that's a quote from Simplicity. Simplicitous. You're just being stupid-rossic. Stop it. All right, now we're done. That was mildly entertaining, I think. I almost laughed. Once. I mean, there was a joke in there somewhere I thought was pretty funny. All right, let's see. He looks like he gets laid by himself. Who cares? That's as good as anything else, frankly. Getting laid by other people means you might get herpes or something. So, yeah, I say, when I tell people to go fuck themselves, I'm giving them probably pretty damn good advice. Because fucking other people is just messy. Oh, yeah, right. I lost the battle. Wrong again. Let's see. What do you think lensing any other science? They look lens to every other scientist. Well, again, I'm just saying the fact that a scientist says something, if you want to say that's all you need, They only say they look lensed, right? They found the same problem I found. So don't lie about it. They saw the images and they can't explain it gravitationally. It doesn't make any sense. And that's why they created dark matter. I don't know whether you heard of dark matter, but one of the reasons why they made up dark matter was that they couldn't make galaxies make sense in just their structure. And also, they couldn't make lensed images make any sense without it. So you want to tell me I'm the asshole? Well, you can say it, but again, I don't think you're proving it. I think what you're proving is that my opposition is just a bunch of weasels who do a lot of shit talking and put up no evidence. You're essentially denying the color blue, so to speak. Now, isn't that amazing? I mean, I show a picture how blue light is twice, okay, as many tons per second. I make a clear point about how blue light is twice as different as red light, and this asshole somehow converts that into me saying that I don't believe in blue light. I mean, you're just amazing trolls. Lying scum. You should get what you deserve. You think lying scum deserves something. If there's some idea in your head that, let's see, what do lying scum deserve? Well, why don't you think about that for a minute? And especially if they were lying about you. All right? And then think about what you're doing and grow the fuck up, cunt. Let's see. Right. If I push was strong, hydrogen wouldn't float, birds couldn't fly, etc. Right. If the push was strong, hydrogen wouldn't float, birds couldn't fly. Well, I don't even know how this makes any sense either. The fact that some molecules actually don't like each other, okay, many of the inert gases are inert for that reason. Nothing will combine with them very well. And they have a great deal of space between each other. There's a whole science that studies that retard, and it has no inconsistency with anything I'm saying. Maybe you're on my side, but I just don't know it. I mean, it's not a really great sentence. Conjecture and conspiracy. So again, more lies. I mean, the fact that it's conjecture, well, I'm demonstrating a logical explanation. So that's more than conjecture, asshole. And conspiracy, where's the conspiracy? Oh, you're not allowed to say somebody made a mistake or they were naive. That's impossible. It has to be a conspiracy. You have to convert what I'm saying into a conspiracy theory. You can't just say people don't pay much attention. Even scientists are lazy, thoughtless, illogical. They're not capable of losing their keys. If light is an electromagnetic wave, then it's bending a bunch with its waveform, yeah. I don't know, science 1, DraftScience 0. Well, whatever. In the end, I'm going to win. And then what's going to be your penance for being a troll, a science troll? If people were trolling Albert Einstein, before Einstein was Einstein, what kind of whack in this face do you think they would have deserved? All right, here we go with wave. Wave is an after effect. Oh, we've already done this part. Sorry. Wow, shit. There's no way to gracefully scroll through this shit. What about time dilation? No, we did that. 28 degrees, half truth. I just ate pussy for fun. What did I do wrong? I don't even know. I just ate pussy for 45 minutes. What did I do wrong? Well, I guess if you didn't stick your dick in the pussy after you ate it, then I guess you didn't figure out what the eating was for. Frankly, I don't really get it. If it's not for the purpose of, preparing the landing pad, I'm not all that terribly interested. I mean, maybe it's a good time for you, but to me, it just seems like a lot of work. Tons move in straight lines, and the field moves in circles around it. Tons move in straight lines, and the field moves in circles around it. No, I'm sorry. No, thank you. I mean, I don't know what that means, but I don't think that's even close to reasonable. Brandon, Brandon, you did it wrong since she took 45 minutes to tell you you need to stop. Well, whatever. How do you know it was a she? Maybe he's a little confused what a pussy is. So what they do at CERN is fake. So here they keep doing this, or is it real physics? Again, it's a real experiment, but have you actually looked at what they do? First off, they're not accelerating light. So why don't you go ask CERN when the last time they accelerated a photon? When did they last bend a photon with magnetism? Why don't you ask them the last time they did that? Because they'll tell you, oh, we can't do that. Yeah, can't get the photons to pay any attention whatsoever. They really don't give a shit about anything you throw at them. You really can't get those little fuckers to do a damn thing unless you put a slit in front of them. I mean, they'll admit that photons only do not. Photons go in, as Feynman said, photons go from point A to point B in a straight line. That's what they fucking do. And it's only when they interact with an electron do they do something else. So what they do at CERN is fake, or is it real physics? Let's see. I mean, I'm just saying, so if you really look into CERN, you'll find out that the 15-ton detector, okay, is like really just a giant cloud chamber with, millions of microscopic technology around it to try to, in some way, find the footprints of these tiny little particles. And their footprints, you do understand that they really can't see any of this. They can only see how it affects something else. So the effects are always hugely amplified. Now, if you kind of understand anything about amplification, you might realize that, like your speaker, if you crank up the volume all the way up, the amplifier starts to distort and it gets kind of ugly. And it happens with almost anything you're amplifying. The more you amplify, the more noise gets into your signal. So I'm just saying, what they're trying to do, the distances they're trying to see are so fucking minute that if you think they have anything called a clear picture, I think you're being a dupe. All right. Brandon, do you think it's wrong since she took 40 miles? Oh, I already did that. Eat butt next. Yeah, well, you all seem like a bunch of people who eat butt. So, I am an anteater nut too. I don't know that. But yeah, I don't know. You people all scare the fuck out of me. I'm sure you all have mechanical dildo machines to fuck you in the butt every morning. But whatever. Humans are quite scary. Let's see. Shit. Okay. Eminem gets head and rides the dick of the Dark Lord Babadork. Baby Dork. Whatever. Well, that comment is just too useless. It's not even a little bit interesting. But whatever Eminem does, it's more interesting than what you've done. I do more interesting things every 12 minutes than you have done in your whole fucking goddamn cunt Weasley life. Yeah, colors, LOL. Yeah, please get off the Ken trip. He is obviously never going to show up or respond. Well, what does that have to do with anything? I'm showing him to be a fraud and a charlatan. That's what responsible people do. You see, most people aren't little Weasley cunts like you. Well, maybe most people are. But people of integrity, okay, they fight for the truth and they defend it against the fakers and the liars. They'll say something about their politicians and they'll say something to other people and they'll write letters and they'll say, hey, I'm not going to take it anymore. You fuckers want their smelly, cunty, dirty, AIDS-covered dick in your ass? That's your fucking business, loser. I don't do it that way. So I'm going to block you for that one. So we'll see you later, fuckhead. I'm not on a fucking Ken trip. I'm on a liar trip. The scientists are lying. Feynman lied. Lots of shenanigans going on. And the last thing the world needs right now is big mouth blowhards claiming they have the truth and they're too weak to defend it. So fuck you. Somebody get this guy a coloring plate. I don't even know what that means. Ken was a kid with all the Transformer toys. I think he was the kid with the Barbie dolls, actually, but whatever. It looks like he gets laid by himself. Well, like I said, not a bad idea. Amendum don't like bullshit, just so you know. Yeah, well, and you're kind of talking some. He would eviscerate in a live debate. Well, I would beat him with logic. Quite factually. I'll explain how, look, you people are just so fucking narrow-minded. I mean, if you just expand your vision a little bit, you might see that many of the things the conventional science is manifesting, like bent space and virtual photons, are completely the world you want to believe exists, which is an ether world. And even my argument that the field is doing the pushing is an argument that's similar to an ether, as long as you make the ether active. So as long as you make the ether hot, we're talking about the same thing, shithead. Okay, Amendum is adding a lot of bullshit. Okay, well, you're done here too. You've demonstrated nothing. You just make accusations. You don't show any evidence. You don't provide any arguments. So fuck off. I mean, I don't go onto other people's boards and talk that shit. So if you can't say it to somebody's face, you can't come into the room and make an argument so I can properly humiliate you. Fuck you. I followed Sam Kennison, pussy eating tips. Well, you know what? I'm sick of you, Brandon, too. You're really not helpful on this subject at all. Go back to the Amendum channel and play around. It's really pointlessly silly. That isn't Spock, apparently. Yeah, I think it might be, but I can't tell. It might be Sarek. Just it's the new. If it's the Spock, it's the new Spock. You know, whatever that guy's name is. Oh, jeez, it's just so stupid. Well, I've already done the Michelson-Morley thing, and it proved absolutely nothing. So yeah, Harry, you're another rude, obnoxious asshole. You can go fuck yourself till dead. You're one of Ken's little trolls. So until you or Ken grows enough balls to make your accusations to my face, you can go fuck yourself, pussy. I only have one question. With are so defensive. You know, again, you think this is let me see you do a room, faggot. I'm sorry, pussy. Let me see you do a room, and then I'll get a bunch of trolls to troll you, and we'll see if you take it. And maybe I'll invite your parents to watch. You get humiliated by 13-year-old trolls. How would that be, fucker? Yeah, fuck you. I'm defensive of nothing but my rights. Okay, jackass? I have rights. I don't treat other people like shit. Until I treat you like shit, you have no right to treat me like shit. That's not a complicated rule, is it, fuckhead? Till I shit in your living room, don't shit in mine. Cunt. There are people here who want to talk science, and you're just obnoxious. And what is Ken? What? I mean, I could repeat the words I read part of his book. His book is full of fucking shit. Fools, idiots, morons, lemmings, stooges, fraud. Fuck you. It's just an ugly example of an unchecked ego. Good night. Well, fuck off and die. Because you're a fucking lying cunt. You have no argument. You've lost the argument in the sense you can't, I can't argue with that guy because, yeah, right, because he's right, you ballless pussy. All right, well, that cleaned up the mess a little. It's so much nicer in here now. Peace and quiet. So, yeah, I think I did what I needed to do to make another argument about Ken being full of shit and fact checking his crap. But again, just this arrogant, I've written 2 books and I've done this and I've done that and I know everything. And all he does is, the book is just, it's just crap. I mean, the whole ferrofluid thing, and, all this chicanery that doesn't have anything to do with a fact as evidence. And most of it's just a bunch of a mixture of quotes, from the authorities. I mean, ironically, as he talks kind of glowingly about Edison. So I guess he wrote the book before he found out it was Edison that screwed Tesla. So his book, he actually includes Edison with Tesla and other people as being, the origins of our wonderful civilization. And so it is kind of funny. And I read Tesla's autobiography. So I know Tesla did a lot more shit talking as he got older. So maybe he, changed his story later. But in his autobiography, he doesn't blame Edison. He blames the manager, okay, at the Edison plant for fooling him into thinking he was going to get paid $56,000 for going to work. I mean, the story is a little bit silly because from what I understand, Edison was cheap. He didn't pay people very well. And, it's kind of like the last man on earth who would offer somebody a $50,000 bonus, which is like $1 million back then. Well, Patrick, I've already explained this, what drives me. I got into this like 4 years ago because, I talked a little bit about the double slit. I saw a Dr. Quantum video. The Dr. Quantum video was just so preposterous. So I started talking about the double slit experiment and just talking about the fact that this doesn't make any sense. Photons splitting in half and having radar and doing all this nonsense. This is silly. And I got so much crap from people. My reaction was instantaneous. It was just like, holy shit, people really believe this garbage. And I was like, nah, it can't be the answer. And so, just that harsh, brutal reaction, like, oh man, I'm offending physics, just made me certain that this is all a bunch of hype and fraud. You know what I'm saying? When the reaction is preposterous, oh, I'm onto something. When people way overreact, you just know I'm getting to them. And so yeah, it just seemed like the thing to do was to do a little research. And so the more I poked at it, right? I mean, once you go looking at double slit, then you find single slit. You're saying, well, that doesn't make any sense. And then once you say, well, interference pattern, what's the difference between it? One professor says it's interference. The other professor is calling it diffraction. You see all the games they play and you start figuring out how this whole thing evolved into this slop that they created out of it. So when you watch enough lectures, you finally see that, yeah, this is just a religion. This doesn't have anything to do with science. It's a fucking religion. If you think you understand quantum mechanics, you don't understand quantum mechanics. That's a fucking scientist talking. Fuck. No, that's what you say about God. Yeah, if you think you know what it is to have God shit on your head, well, you don't know shit about God shit. So anyway, so thank you to Piro and a few other assholes who just insisted that the science is right. These are the most reliable equations in the history of mankind. And if this is the most proven, greatest science ever, the, wave theory of silly putty. So anyway, so I just thought there has to be a better answer, because the silly answer that the smallest, dumbest thing in the universe has the most interesting life, that they can do the magically powerful things, just seemed too fucking silly. And it just seems so convenient too, right? That the smallest thing in the universe, the thing with which we have no hope of ever seeing it, It's the thing with all the special powers. Doesn't that just seem a little bit convenient? The one thing we can't see, well, that's the special power box. All the special powers come out of there. Yeah, fuck that. Too obviously, just no, that can't be right. Too convenient. And no one else has the balls, I guess, right? That's the thing. Nobody has the balls to take on Einstein. And, they're all afraid to look stupid. And I guess I just wasn't afraid enough to look stupid. So I took the challenge. And, wasn't that hard. Seems like the particle moves with a defined set of movements, and by the time it hits a wall, it is that particular position. Also, as the particles move, they seem to be distinguishing simultaneously, disentangling. Oh, that shit is happening. I mean, you just didn't listen to me, did you? Feynman, a real guy who believes in quantum mechanics, but a guy who knows that's just math. It works, but it's probably bullshit. That's basically what Feynman believed. Okay, I mean the real story. Okay, when Feynman got real, he said it even in one of his lectures. He says, "Look, cut through all this horse shit. Photons go from point A to point B in a straight line, and the only time they don't do that is when they hit a fucking electron. Do you hear me? There's no entangling in any other way. Disintegrating? I don't even know what that means. Disintegrating? How do photons disintegrate? I don't. What experiment shows photons disintegrating? Sorry, I can't see worth shit today. I have resisted conceding that my eyesight is failing, but it does get better. So that's the good news, right? I have days when everything's just a little bit fucked up. And if I wait a couple of days, it gets better. But the particle is breaking into smaller pieces. I don't know what you're talking about. There's no evidence you can break a photon into pieces. But all still causing the same reaction on the wall. Oh, well, I'm sorry, none of this is happening. I don't know I don't even know what you're talking about. What experiment demonstrates photons breaking into pieces? It just doesn't make any sense. Oh, whatever. Fermi would know. What the fuck does that even mean? Ugh, annoying tripe. Fermi was just a fucking manager, to tell you the truth. He wasn't all that, you know. I don't know if what is happening. I was guessing. Well, I'm just saying, what use is it? I don't want your irrational guesses. I've already given you an explanation that, in my opinion, is rock solid. Okay? Photons hit electrons. Electrons accelerate. And then when they stop, they readmit the photon. That's conservation of energy. Do you understand conservation of energy? I jump on the skateboard moves. I jump off the skateboard can stop. And I'll go off moving again. But I might go off in a different direction if the skateboard doesn't go straight. So if the electron is in a field, the electron won't move straight, and he'll emit the photon at an angle. You can't understand that? Fuckhead? Well, we're not talking about accelerated particles, are we? Or isn't it the subject of light? Light can't be accelerated. Oh, fuck. Just no point. This isn't helpful, okay? Whatever you're doing here, this mush of incoherent speculation that isn't related to the subject, just isn't very useful. The crap they have found in accelerators doesn't prove or disprove any mechanical theory. It really just doesn't. It's of almost no value because most of the particles they've found, most of the bits they've created, are not bits that have any character. They can't be sustained outside of the lab, so to speak. They're Frankenstein monsters. They don't really probably have anything to do with the real mechanics because they're just little pieces they've broken off. There are molecules in the air with a particular charge holding them together. As the proton flies, it must interfere with the matrix of particles in the air, which may not be random. Photons don't do a bunch of flying. Oh, okay, you said photon, not proton, sorry. Again, this conversation I've already been through. I've explained rainbows. I've explained these different interactions, but they're exactly that, interactions. It's like ultraviolet light actually transfers a bunch of molecules into ions. And eventually, if you expose enough light, it changes them all into ions, and it doesn't have anything to change or convert anymore. And the filter actually breaks down, and then the ultraviolet light gets through. There's all kinds of circumstances like that. That's why the sky goes red. You see, it's because when the sun's at a bigger angle, it's using less of the chemistry. So now the chemistry is able to filter out the blue light. But when the sun's overhead, it burns through the chemistry, and so the ultraviolet light gets through. These are phenomenon, but I don't know if they're really relevant to this particular conversation. They have nothing to do with particle theory of light. How do I know? I mean, I get another stupid argument. I know because I've made videos explaining this. It unifies physics, retard. Okay? If you particleize this, you can make gravity, magnetism the same fucking force, asshole. And photons are just another element of it, a visible element. But it's all the same fucking thing. And the only thing you're changing is frequency and polarization. You know what they do in the lab? Yeah, you can find out what they do in the lab. All right, I'm just going to block you. I'm sick of you. Fuck you. You're not making an argument. You're just fucking talking about people's labs like that proves something. A lab doesn't prove anything, retard. Yeah, I won't block you, but one more douchebag comment, then I'll block you. Wasting my time. I know what super colliders are. I know more about this shit than you do by a long shot. And I've only got 300 videos on this fucking channel that you obviously haven't decided to watch. And so what's the point? I'm supposed to personally instruct you on everything? Just fuck off. I mean, these people who think they're entitled. Oh, personally tutor me, Gary, about every element of physics in the universe. Not just the ones you're arguing. Yeah, not the ones relevant to your theory. People. I mean, people are just assholes and cowards and cunts and slanderers and liars. I mean, it's just so few humans on this planet. Yeah, the rest of them are just so despicable. Let's see. No one has ever made an experiment using a laser which accelerates photons. You can't accelerate a photon. It moves at the speed of light. Period. Always. in mediums, the photons will be caught in electrons and they'll slow down because they have to travel inside the electron. They have to spread their momentum throughout the electron, so they still are moving. They're just doing this instead of a straight line. And then when they pop out of the electron, they go straight line again. And then they go into another electron and do this jiggly shit some more. And then they go straight again. In fact, the actual ton is just going straight through, and the polarization is really the thing that matters. The photon hits another quanta and exchanges polarization. So the polarization stays in the electron, and the momentum is transferred. So it's really just a transfer of momentum to the ton that's in the matter. So if you thought of it as the matter just being one color of quanta and the other quanta being different colors, you can sort of get the idea of what might be happening. So matter is the blue stuff, and the outside forces are the green stuff. So when it shoots in, what it's doing is it's giving this blue piece essentially the momentum of the green piece. So if the blue piece was going this way, the green piece hits it, and now the blue piece is going to go that way, and the green piece is going to go out that way. So it's exchanging momentum, but the matter keeps a pocket of polarization. And because this force is always on the outside pushing in, like gravity, these pieces don't really get out because they reflect off all the greens. So when a blue hits a green, it bounces off. The green goes that way. The blue goes this way. So it constantly jiggles inside the electron. And you can see that that would be a lot of distance doing this, hitting off the inside walls, bouncing and bouncing and bouncing. Lots of distance being traveled, but I'm not going anywhere. You get it? So that's what happens inside of electrons, and that's why interactions with electrons takes time, and it will slow the photon down, but it really didn't slow it down. The photon just left, but it's wearing a different color suit and you didn't see it. You know, it went from having a suit you can see to not having a suit you can see. And then the electron just makes a new photon later. It just makes a new one. It's just fooling you. In a sense, it just allows the guy in the blue suit to leave. See? That's how it works. The blue suit leaves, not the con. So it's just a suit. It's a hat. It's a hat. Matter is just the hat. Okay? The people just keep flipping the hat. Oh, you wear it. Ah, you wear it. Every time you bang into somebody, you just exchange hats. And there's, you know, the hats you can see and the hats you can't. But yes, you can't accelerate a photon. It's the constant. It's what makes the whole universe work, is that all the forces move at exactly the same speed. The quanta all move the speed of light. The hats don't. I don't know why you're asking this question the same way again. Do you know what goes on inside of CERN? I mean, I don't know what that even means. Well, yeah, I know that they have big, giant, super cooled magnets, and I know what an accelerator does in terms of it keeps pushing it's like making a racetrack smaller and smaller and smaller with a car that has a constant speed. As you make the track smaller, the speed increases. Yeah, that's how they accelerate things. I know that. Well, radiation is a tricky word, isn't it? As I just pointed out, all quantized radiation, all quanta, moves the speed of light. Anything that's material, and that it's a bunch of quanta stuck together, has rotational speed, so it's going to be something less than the speed of light. So, yeah, but a clump of radiation, that's a whole different subject. You can have radioactive heavy element. You can have ions that are radioactive. There can be lots of subatomic particles that can leave radioactive material, and people will call that radiation, but it's really not radiation. It's a clump of radioactive material that leaves the material. But the actual radiation, the actual gamma rays, are photons, right? Beta, I don't know which rays, but the real ray part, cosmic type ray part of radiation, is just like any other ton. It's moving the speed of light. It's a kind of light being emanated by the radioactive material. Oh, now black hole bullshit. So what force is in a black hole, and is a black hole proven to be real? No. You should put a question mark after that one. Obviously, they've never found a black hole, or we'd have pictures of it all over the place, right? Because it would be lensing the fuck out of everything, right? Technically. So then we'd have some really great lensing images if we actually had a picture of a black hole. So obviously, they don't have a picture of it. And I would say the theory of a black hole is made out of mush, and it's made out of, it's sort of Einstein's fault that, you know, by creating this gravity well thing, they just kind of, the math doesn't have a stop to it. Okay, the math doesn't say you can't go any further than this. The math kind of says you can just make the well forever. Now, if you kind of know anything about physics, you know that having an infinity somewhere, affinities are like really bad farts. You don't want to have one of those in physics. So obviously that's a bit of broken physics in the sense that you're stuck with an infinity that just creates all kinds of problems. So they can make the well, they just can't make matter to fit in it, because then they have to say, we compressed all the mass in the universe into the size of a grapefruit. Well, how did you do that? Because the electrons and the protons won't let you do that. I mean, there's no physics in the known universe that allows you to do that. So to explain a black hole, you have to explain how you compressed matter, which means you have to explain how you got electrons to stay right next to each other without complaining in some kind of major way. So I would say it's unlikely you're going to find black holes that have solar masses of millions of suns and that kind of stuff. I think those are preposterous monsters that they'll never find evidence of. And I think it just makes no sense from even their own field view of the universe if these monstrous things were lurking out there and they had consumed that much matter, they'd have to be moving. Because when you consume matter, you consume its velocity. You're stuck with its momentum. And you have to do something with that momentum. Oh, you know, there's no point in even starting a sentence with if the electrons cannot be near each other. I mean, that's about one of the most solid parts of nuclear physics, is the understanding that electrons are charged by what they call negative charge, and that those charges, like magnetism, you can't, they just aren't compatible charges. And part of that charge is part of what creates the strongest nuclear forces. I mean, the proton-neutron force is a more important force, but you know, the repulsion between electrons is the second strongest force known in the universe. So there's really not much of a doubt about that one. I mean, the circumstantial evidence for electrons being the carrier, that electrons emit polarized energy, gravity, that is repulsive to other electrons of the same polarity, which means it's like this green argument. You know, the electrons, this is, I would say red, I'd use red and blue as the example, but the electron is basically spewing this green crap. And the green crap is exactly the kind of crap that pushes the electron. So obviously, if it produces a bunch of green crap, the other electron is producing green crap. They're both producing something that's going to reflect off of them, and they're going to find it very uncomfortable to be near each other because they're going to keep throwing rocks essentially at each other. So if they're just sitting around and rocks are being converted going through them, so the gravity pressure goes through them, acquires a rock, okay, and now has a rock to push electrons with. I don't know how to say it exactly the right way because it's the hat argument. But yeah, once you have a hat, you're important, and you get on the subway, or however you want to put it. You have power, and you have the power to push the other guy because he can't eat any more green stuff. And the doors are closed, and you keep producing. It's like illegal aliens. You keep making illegal aliens, and it's like the electron can't take no more illegal aliens. It just can't take them. So it's running the fuck away. When nuclear weapons go off, what is occurring then? Well, actually, it's kind of ironic if I give you the true answer. So I'm going to give you the truth. I'm not going to bullshit because of my force theory here. The truth is, the nuclear bomb is going off around us all the time. There's enough, the amount of energy in the quantum field equals the same energy. You can never change how much energy is in a pile of space and how many quanta. But as I pointed out, the ones that matter are those ones wearing hats. And what a nuclear bomb does, it releases a ton of quanta with hats. So it's like Africa blew up and, 50 million illegal aliens were created, and all the continents start running away. No, that's not a good example, but you know what I mean. So what I'm saying is the polarization that's inside the matter is released, and it's polarized, specific polarization particles that have power to disrupt other material bodies. So the very thing that I find dangerous is the very thing that keeps coming at me. So if I was made up of straight bars going up and down, this is just a metaphor. If I was made up of straight bars going up and down, think of gravity as being frisbees on end, so I don't feel them. And think of other forces as just going right through me, like a radio wave or something goes right through me, right through the bars because it's of the right polarization. But some polarizations, they hit the bars. So they're going this way. And so what a nuclear bomb does is it releases a ton of quanta, in the sense that it releases the wrong word. It lets the hats be exchanged into the real world. So the hats are now put on stuff going out, and it's all hats going out. But that's the same as the frisbees doing this. So it's just that everything starts frisbeeing this way, and that just starts beating the fuck out of my matter, and then my matter turns into a bunch of loose frisbees. The hats get released. The polarization is released. And it's just, we can feel the polarization. We can't feel the stuff that doesn't have the right polarization. It goes right through us. Nothing happens. It's only certain kinds of quanta that fuck our matter up. Not a perfect explanation, but I think you get my point, maybe. The energy was artificially grouped together in a way which is contrary to what would occur in nature, and then, whatever that means. Obviously, radioactive elements occur in nature, The only thing that makes the bomb, the bomb just is that, yes, you collect a whole bunch of that stuff that's radioactive, and then you try to make it even more unstable by filtering it and cleaning it. And yeah, but the very point is it can sustain the nuclear reaction, which is one neutron goes in, right? A nuclear reaction basically is a neutron goes in, fucks up the bonds of the protons, okay? And so it disrupts the atom substantially, converts it basically. You're basically doing alchemy. So you're changing this big atom into two smaller atoms, like a borite and a snotite or something. But anyway, the point is you have these leftover bits, and which end up is with two neutrons coming out. So one neutron goes in, two neutrons or three neutrons come out. Like in a hydrogen bomb, I think it's three neutrons come out. So it's a 1-to-3 ratio. So obviously you can understand that's a chain reaction, right? Because those three will do exactly the same thing. They'll crash into the nucleuses and bust the fuck out of them. And three more, so you go 9, and it's just this exponential growth of all these free neutrons. And so it just keeps splitting all of the atoms. And as it splits them, it has a huge amount of leftover parts. And that's basically a nuclear bomb. It's a bunch of leftover parts that are liberated. So a bunch of unbound hats go flying into the field. Well, I don't know what not all of them means. It's not really useful. I don't know. Obviously, not all material is radioactive. Where did I didn't even imply that all materials were radioactive, did I? I would argue that all materials can be part of can add to the consequences of if you're going to manufacture a good bomb, you could manufacture it by layering different elements through the reaction, and especially if you want to make a bomb that leaves behind a lot of residue, a lot of radioactive residue, a dirty bomb. You can certainly use creative composition to maximize the mess your bomb will make. They're using isotopes of materials. Well, it's minerals, aren't they? Well, that's a tricky question. I mean, you're talking about atoms that are already incredibly unstable because they have like 250 fucking protons in them. I mean, they're big, heavy elements. They're big, giant atoms that are at the limit of the size limit. So they're really fat, and they're really easy to fuck up. So yeah, but I don't know what that means. I mean, in a sense, they're all unstable, so they're always some sort of isotope. I mean, once you start having 250 protons, it starts to get to the point where, well, you can have like 200 electrons, or you can have 250 electrons. So, I mean, defining an isotope gets a little complicated because, usually isotopes are just created by an imbalance in these numbers, the number of protons to electrons. But, like I said, it's like all of the radioactive materials are essentially some kind of isotope, and that the imbalance is likely to exist. I mean, even carbon does it. I mean, you have carbon 12 and carbon 13, and you have lots of different carbons. So, no Australian guy today. Now we'll give him till after 2 o'clock. Wonder what time that is this time. Might be probably 1 o'clock. Yeah, probably 1 o'clock Australian time. Well, I guess it depends on where you are in Australia. Kind of a big place. Four years is a long time. Well, I don't know. Part-time for 4 years. Yeah, I thought, I had it like, the first year I had a pretty good, I thought, particle theory of gravity. But, that's why I made this channel. So I came out and I tested it. And, yeah, people made some arguments that, oh, yeah, all right, I got to fix that. I got to fix that. So I had to fix it. And so it has taken longer than I thought it would. But, the last... Well, it just keeps getting better and better. I mean, once I did this whole arrow thing and the idea of the, quantizing the, once I let go of the idea that electrons have to be orbiting protons and that the inside of an electron has to be made up of swirly shit, that was a mistake because, yes, the geometry gets squarer and squarer as you go down. It doesn't do the circle thing anymore. Circles are an illusion, and it's even true of things like the Earth and the orbits. They're at least they're really angular. They're really things are doing the staircase thing. Nothing's really doing this pure circle thing. The protons and the neutrons don't really do circle. I mean, they do circle in the terms that their shape is going to be defined by spherical rules of pressure. Even pressure is going to create spheres, but their movement isn't dictated by, I don't think, as much spherical nonsense as I originally thought. I kept trying to do the mechanics, is the fractal thing. It's not a fractal. The little bits are not really acting the same way as the big bits. Gravity isn't a big bit force. Gravity is a nuclear force. Gravity is affecting electrons and protons and neutrons. Gravity isn't affecting things. Mr. Spock is not being moved by gravity. The atoms, the protons, electrons inside of Mr. Spock are being moved by gravity. That's why I said what I said about how they hit the wall. Well, I still don't even understand what that means. So this hitting thing is a dangerous concept. You have to kind of use words like absorption and reflection. It's kinetic. Kinetics don't create remainders. They don't create friction. They don't create stuff left over. They have complete interactions, not incomplete interactions. Appear to your eye. Well, you can't really, again, appear to your eye when you're talking about photons is almost ludicrous, right? You can't watch a photon go somewhere. You can only see photons that are going into your eye. Even if you were watching a laser beam, obviously the laser beam light you're seeing is light that's never going to the target. The light you're seeing never got to the target because it went in your fucking eye. Well, what hits the target, I think, is perfectly reasonable that it hit. I'm just saying there's no point in arguing with the results of the experiment. The point is how do you explain it? And I'm just saying the easy explanation is diffraction. It's a function of They used to call it quantum electrodynamics, and that's what they should have stayed with because it's just electrons. The game is electrons. Electrons make things happen, not photons. So anyway, I guess that's enough for this evening. And did what I intended, I think. And yes, thinking's a good thing to do. And uh, research also helps. Like I did in the last 4 years, I did have to watch an awful lot of physics lectures. You know, I couldn't just pull all this out of my ass. Actually, I did have to do some learning curve shit. So, but I did a good job of it, actually. Yeah. So it worked out so far. I mean, it will eventually. I mean, there's just, I would stake my life on it. I mean, I'd stake the cat's life on it. I would, I don't know if I'd stake my family members' lives on it because that's getting a little rude. But I'm really so confident that I've got it. Just it fits so perfect. Explains every goddamn phenomenon and unifies everything. It's all one force, polarized frequency, really simple. It's a checker fucking board. I've reduced all of it to this simple mechanism. All the conservation rules are obeyed. It's just too perfect. It's got to be the answer. I don't know what new cape means, but I don't know. I got a T-shirt. Yeah, it's getting colder. Have to wear some clothes. But anyway, cape equals vape. Oh. Yeah, no, this is an old one. It's just that obviously the battery only lasts so long, and then I have to go back to my jury rig. So you just unscrew it. You think just a battery on there. And it's pink because it was $2 from China. Yeah, so the pink ones were cheaper. Yes. It really has saved me $1 zillion. I really should be able to buy a yacht with all the money I've saved, not having to buy real cigarettes. But I do miss them. I got sent 2 packs this week, and I smoked them in about 2 hours. Yeah, it was really amazing. I think I might have gone through both packs in less than 24 hours, which was really stupid. It was probably a little longer than that, but because I really tried to drag out the last pack, but it was just, I love smoking. I miss it dearly. Yeah, I've done some. I got magnets and stuff. Yeah. And I got Mr. Spock to help. He holds the magnets. He holds the magnets for me. And we do all kinds of interesting twirly about experiments with the magnets and whatnot. I put the magnets near them and they go, oh, it's amazing. The lightsaber's moving all by itself. Oh, it's amazing. Yeah, it's all quite incredible. But he's always carrying a pipe bomb with him. I don't know. Terrorist. So yes, I have done some experiments. I've done lots of the laser fiddling around here and there, but I need a laboratory. I can't do this shit on my desk. It's just too messy. And I try to do other shit, and I knock crap over and break it, and it's just so annoying. But yeah, you really need proper place to do experiments where you don't have to touch them, and you can set it all up and all that shit, and you don't have to take it apart every 15 minutes. And um, so I'd like to do better experiments, but actually, there's people online that have done the experiments, pretty good stuff. There's some where I'm just like, oh, I wish I could tell him to move that 2 inches to the left just to see what would happen. But yeah, you do what you have to. Can you use this? Can you use the propellant item? I don't know what that means. Yes. Well, yeah, I mean, there's probably implications to this, in the sense that it will open up some areas for development. Like maybe it is possible to blow up the universe. So I might be able to find a way to do that. Very simple. It's just the right resonant frequency, right? So you just play the right tune on the piano, and boom, it all blows up. So there's hope that this will bring about some beautiful technology. Two, I don't know where the two goes. This understanding of quantum physics, question mark, in a non-traditional way. And there's a two somewhere. To a non-traditional way? No. To into non-traditional, in a, to, in a, yeah, I don't know where the two's supposed to go. But anyway, yes, this is going to. Oh, look, I'm saying that lensing doesn't happen. So I'm saying the Hubble telescope right now can prove it doesn't happen. Okay, right now it can prove it. And so there are things that are going to come out of this that are going to change what people think the truth is in kind of substantial ways. And light doesn't bend, and it only gets diffracted, and yeah, well, you certainly don't need a complex model of the atom. The atom isn't nearly as complex as they're making it. It's just a ball of crap, uh, almost like a water drop. It just doesn't have a choice. Like, for instance, a small plane. I don't even know what that means. A quantum propelled plane. Energy is still this hat thing. Okay, there's lots of energy, but energy is only meaningful to material objects if it's wearing the hat, if it's of the right polarization. So that's the trick. To filter something for the right polarization takes energy. So that's why the equation always ends up being one where you have to put just as much in to get something out. So everything is just a battery, and there's nothing that can really make energy. So you have to take energy from some other. You have to take polarization from one place and move it to your pocket, and then you can use it from your pocket. But you can't just make energy and then put it in your pocket. You have to take it from something. And the taking is the tricky part, because that means you have to reach out and you have to apply force to get it to go in your pocket. And that's when you lose the value of it. But there's lots of energy. I mean, there's no doubt about it that if you just want to move stuff, obviously atoms have a ton of hats in them, and you can move shit by letting that stuff loose. But the trick is letting it loose without blowing your hands off or your planet off. So yes, it would be perfectly possible to have a nuclear-powered, paper airplane. There's no theoretical obstacle. It's just that it's going to be really hard to make the nuclear power plant that can do that. Obviously, you have to be a nano plant. So anyway, I think I can have done my job for the evening. And I will attempt to move on, try to get my life back in order here. Still got to fix the websites. It's still, GoDaddy is half fixed, but it still isn't fixed. So I got to get them to fix some more stuff, or I have to move everything over to the other servers and such. But that's a pain in the ass. I got to work on my arrow thing, and I have a ton of shit I have to do here. I have to crawl under the house one of these days, prop the damn thing back up. But anyway, and then I have to do physics research. Just a very, very complicated life. Then there's things to worry about too. I got all that worrying to do. Oh shit, so much to worry about. Yeah. Anyway, till the next time, I and whoever this is, I wonder if it's his moves. Hey, it does. I wonder if I can pull his head off. Oh, I want to. Leave his head there. But it does move a little. I'm looking that way. Oh, it imbalanced me. I had a tipping point problem. Yes, I'm not quite as stable when my head is turned. All right, we'll turn his head back. Yeah, it's funny. Little things make a big difference sometimes. Well, do I seem like I reside somewhere other than America? I mean, realistically, do I sound like a boot Canadian or something? Do I talk like a boot Canadian? I don't think so. No. And where else would they let somebody talk like me but America? Right? All the other countries, they all talk like twats. So I gotta be American. Simple deduction gets you to the correct answer, I believe. Only in America. Yeah. So anyway, till the next time, and the such, and so forth and the whatnot. Part of this was fun. I like doing the Ed imitation, so it's always fun to do a little bit of Ed. So yeah, I have to admit, I miss Ed. Anyway, till the next time, fuckers. I'm leaving this time. I'm going to hit the stop the broadcast thing. How many minutes is this anyway? Didn't it say somewhere? Yeah, I mean, fuck. It should say somewhere in this old stupid pukey screen. Damn. I thought it did say somewhere. At one time, it seemed to me that they did have some kind of thing that said how long I've been doing this crap. But anyway, it doesn't really matter, I suppose. I don't know what good the information would do me. I could look at the clock and surmise that it's 2 hours and some cents. Okay, that's more than enough. So thank you very much. Yes, and good night, Amanda. And I make videos soon, probably. Yeah. The answer is usually yes to any question you ask. So yes, it's always yes. Yes. So yeah, go ahead, ask me a bunch of questions and just answer them yes, and it'll be great. Probably. And such. So anyway, I must go.